Alright, so once again, this is workbook page 88, and we're just adding some notes to our homework. First off, this entire page, 88 and 89, which is, if you can see on your board, that's part of your homework. This is all about the perpendicular bisectors. Now, what they're doing on this page is they're only dealing with one segment on this page. And there's only one perpendicular bisector with one segment. We're eventually going to get to triangles that have three perpendicular bisectors, but we need to focus just on one first. Remember that perpendicular bisectors, they only work for segments, because you have to be able to be perpendicular to this thing, and it's got to bisect it. Can you bisect a line? Can you bisect a line? No, because there's no ends. Like how do you know where the midpoint is? A line continues in both directions forever and ever. So we don't know where the midpoint is, so therefore we can't bisect it. Can you bisect a ray? Bisect a ray? No, because it's, yes, it has a starting point, but then it goes on forever and ever and ever and ever and ever in one direction. So how do you know when you eventually get to the midpoint? Because it just keeps on going. So you can't bisect a ray either. Then some of the other objects, an angle. An angle consists of two rays. Well, you can't be perpendicular to an angle. You can't be perpendicular to both sides. Okay, so I'm just trying to explain to you why perpendicular bisectors only work for segments. You can't have a perpendicular bisector of another object. And then we know that the segments that eventually we're going to be talking about sides of triangles. And there's three segments in a triangle, the three sides, so therefore a triangle has three of these perpendicular bisectors. The next thing we need to add is any point on, what does this symbol mean?
Perpendicular.
Perpendicular. So any point on the perpendicular bisector, let's go ahead and write this, any point on perpendicular bisector is equidistant from the two endpoints of the segment. I'm sorry that my handwriting is so atrocious, my bad. But it says equidistant from the two endpoints of the segment that you're bisecting. Any point at all on that perpendicular bisector. So if we look at an example, let's look at number 1. It tells you our end goal is to find the length of segment AB. So we need to eventually find out what the length of this segment is. But first, let's just figure out what the heck is going on in this diagram. Okay? Is there a segment in this diagram that's being bisected? Which segment is being bisected, being cut into two congruent parts? Segment AC. So this guy, segment AC, is being bisected. The end points are point A and point C of this segment. I know it's being bisected because there's these marks of congruency that were in the diagram. Well, we're trying to find this perpendicular bisector. So is there another segment, line, or ray that go, so what does that mean? Sorry, what does that mean about point D? My bad. What does it mean about point D?
It's midpoint.
It's the midpoint. Right? So if you have a perpendicular bisector, it's got to go through that midpoint. So, is there another object in this diagram that is perpendicular to that segment that's being bisected? Segment BD is perpendicular. Very good. So, what could I call segment BD? Not a trick question. What is segment BD then? If it's perpendicular and it's going through the midpoint, meaning bisecting segment AC. It is the perpendicular bisector. It is the perpendicular bisector. Because, now just go slowly, one step at a time, right? Perpendicular, and it's bisecting, so it's the perpendicular bisector. Okay? It's not a mid-segment. It's not connecting two midpoints. We don't know if point B is a midpoint, but it is perpendicular and is bisecting, so it's a perpendicular bisector. Is it safe to say that point B is on the perpendicular bisector? Absolutely. I can extend this segment and make it into a line if I wanted to. So now this is line BD, and this line is the perpendicular bisector. Well, point B is on that line. What's true about any point that's on the perpendicular bisector? It's equidistant from the endpoints of the segment. Now that word equidistant, it's kind of a big word, but we can just break it up into its two parts. Equidistant. So it's just the equal distance. It's the same distance away from those two objects. It's the same distance away from those two objects. So if I hold my hands out here, my hands are equidistant from my chest, if I'm normal. So equidistant, same distance away from. What that means is I can pick any point I want on this perpendicular bisector. I can pick any point I want, and that point will be the same exact distance away from the two endpoints of the segment that's being bisected. So this distance here is the same exact distance as there. You can choose another point if you wanted to. How about a point right here? As long as it's on the perpendicular bisector, that means it is equidistant from the two endpoints of that segment that's being bisected. Even if it goes below. So even if there's a point down here, it's still on the perpendicular bisector, therefore it is still equidistant from the two endpoints of the segment that's being bisected. So we're all okay, and we're all comfortable with saying that point B is on the perpendicular bisector? Okay, so what's the relationship between segment AB and segment BC? What's that? They have to be congruent. Why?
Because point B is on the perpendicular bisector.
And what is the implications of this some point being on the perpendicular bisector?
The line, yeah, segment of BC is equidistant to BC.
That means that point B is equidistant from the two endpoints, making this segment the same length as that segment. Two segments have the same length, and they are congruent. Okay? So how would I solve for x? What equation would I set up?
2x equals 5x minus 6.
Set the two expressions equal to one another. Okay? So this is just one segment, this is just one perpendicular bisector. Excuse me. And so that's how you will do number 2. That's also how you'll do number 3 as well. If you look at the diagram for number 3, what segment is being bisected? Go ahead and raise your hand and tell the class. What segment is being bisected, being cut into two congruent parts? Caroline. Segment CA is the one that's being divided into two congruent parts, or split into two congruent parts. So, is that the perpendicular bisector? Is the one that's being bisected, is that the perpendicular bisector? No, the perpendicular bisector is one that's doing the action. It's the one that is actually bisecting another segment. So in our diagram, which line or ray or segment, what is the perpendicular bisector in number 3? Line BD. I could call this segment BD if I wanted to, but this is the object right here that is perpendicular, and it is causing another segment to be bisected. It is the bisector. It's the one that's doing the action. So this guy right here. I bring that up because you need to be able to identify which one is your perpendicular bisector so that you know if you have a point on it or not. Because any point on the perpendicular bisector is equidistant from the two endpoints of the segments. You have to know which one's the segment that's being bisected versus which one is actually doing the splitting into two congruent parts.